Hello and welcome back to the shop. Today I'm going to talk about one or two things to do with the drives on the machines, and we're going to have a look at a little project that I was working on last week which I've completed now. So the first one, we'll have a look at the drives on the machines. Right, we're next to the metal shaper here, and I thought I would just go through the electric motor drive and inverter here on the side. Somebody asked a question about the drive on this unit. They were in the process of restoring their own machine, and they may be looking at putting an inverter on. Right, let me just check to see what it says on the invoice here that I had from the company. Now the company I had this drive from is a company called Newton Tesla, and they're based here in Britain. They're actually in Warrington, Cheshire. And they've got a website, and the website is www.newton, that's Newton Tesla, TESLA, as in Elon Musk, .com, but nothing to do with Elon Musk, I don't believe. Right, they're a Mitsubishi dealer as well by the looks of it. So I think the unit in here is a Mitsubishi one, I'm not sure. But anyway, when I looked on their website, I wanted an inverter drive for this, and I knew the horsepower of the original motor was half horsepower. It says it in the literature for the Atlas shaper. So I thought, right, okay, we know what power we need half a horsepower. So I thought, I didn't want the hassle of buying an inverter myself, selecting the correct one, getting it, finding it's not suitable, sending it back, getting another. I thought, no, I need to buy something that's already sorted out. I've got too many other things going on, and when I put this together last year, I'd only just moved in the property here, so I'd got a lot of other things on. I thought, I want to buy something from someone who's an expert in that field, and I don't want the hassle of messing around. And I was looking around on the internet, and I found this company, Newton Tesla. I'd actually heard of them sometime in the past. I can't remember from where. But anyway, if you look on their website, they've got some interesting drives. And they put together a package drive for conversion of certain types of machinery. And in the description here on the invoice it says, well, this is an AV400. So it's an AV400 0.5 horsepower package to suit Myford ML7, ML10, Speed 10 Boxford lathes. And now we could actually add Atlas 7A and certainly 7B shaper. We could actually add that to that, because this has proved itself capable of operating this machine, no problem whatsoever. So I'll just put this down, and I'll bring you in closer and we'll just have a look at what we've got here with this drive unit, what you actually get here for your money. Let me put that down there. Right, I'll bring you in closer. We'll have a look at the inverter, so I'll bring you down here first so you can see what it looks like. And then we'll have a look at the motor around the back. Alright, this is the inverter unit, the control panel. Everything's in here. Alright, you can see AV400 high performance speed controller, high torque variable frequency, designed and manufactured by Newton Tesla. That gives you the information there. It says here, input supply 200 to 240 volts AC, single phase, 50 to 60 hertz. So we'll do 50 or 60 hertz. So obviously it's going to be suitable for here in Britain, but probably suitable for the United States as well, being 60 hertz, but I don't know. I'm sure there's people in the United States who make this kind of thing. Output supply 0 to 200 volts AC, 3 phase, 5 to 60 hertz. So that's the output going to the motor. Power rating 0.4 kilowatts. So what's that? That's probably about 5.5, 6 0.5 to about 0.6 horsepower. output current 2.5 amps. So there we are. Now on this unit we've got an emergency stop, obviously. Start. It's in jog mode at the moment. We've got a start. You can't see the RAM moving there, but it's moving nice and slow now. We've seen that before many times, haven't we? When I've been messing with the shaper. And of course we've got a stop. But the emergency stop takes everything out. See? Can't run. Right, we've got a forward and we've got a reverse button here, a select. I never run this in forward, it's always in reverse because it's the correct direction for the rotation of the components in here to give us that slow power stroke forward and that fast retract stroke on the return. On the potentiometer here we've got a jog facility, so if you bring it right the way back anti-clockwise here, you've got jog. So jog allows you to do this, obviously. Yeah. And if you just move it, there you are. It's now in run mode. See, it's going on its own. Yeah, you've seen that before. So there we are. We've got quite a bit of control feature there. The speed control, it's going to be from about 100 to 1800 RPM on the motor. I don't know how that's calibrated. Perhaps I need to get a tachometer and just check that calibration with this to see how close it is. But you can see if that was on your lathe, that'd be ideal. You've got a forward and reverse control. You've got a jog facility, really useful. I do use these kind of facilities on my Myford lathe with a great deal of benefit. So there's the inverter drive. See, you can't, it's all pot riveted together, you can't strip it down. But there you go. Whether this meets the electrical requirements in your own countries, I don't really know. I don't know. I know the United States it would have to, is it NEMA standards that have to be manufactured too. When I was working, when we supplied equipment to the United States, they actually sent motors over to Britain. We would build them into the machines and then send everything back. And that was to ensure that the electrics complied with the United States requirements, with NEMA standards. But anyway, you'd have to check all that stuff out. But like I say, you've probably got there'll be many people, wherever you are in the world, who'll do this type of thing. You might want to do it yourself. That's your choice. Let's have a look at the electric motor, which is hiding around the back. Right, you're looking direct at the electric motor now. You can see it here, you can see my hand. I've got a little tripod that the camera's mounted on. So you're just sitting on the bench behind the shaper. Alright, you can see there's your cable in. One or two little modifications I made here, I had to, because this electric motor, the base will not fit direct. You take the old Atlas motor off, the base, the hole centers don't quite fit. You know, a little modification to do. There was actually a crack, where was it, on this mounting here. So what I've done is I made a plate that went, where is it, that way? I've got two plates that way and that way, which clamp everything together, which makes it quite rigid and solid. But you can see it's one of these motors where you've got rubber mounts at the ends here, so there's a bit of flexibility there. What I did, I replaced the pulley for the drive. I don't know if you can see that, just see it there, can you see? The pulley, the original one I think is 2 inches, something like that. And this one's a little bit bigger now, I think 2.5, I can't remember now. I'd have to take the guard off or have a look to see. But what we did is I bored that out and I cut the keyway on the lathe. I've got a special keyway cutting attachment on my lathe. And that was before I had obviously had the shaper going. Certainly before I had the planer going, and certainly before I had the milling machine going. Because I have got a slotting attachment for the milling machine, but these attachments for the miller are too big to lift up I've got to build a little jib crane to attach to the side of the base to lift things on and off. But anyway, we made a new pulley. I bought the pulley blank. It just had to be bored out and keyway cut. Fitted new belts. The old belts were completely decrepit, and one or two other bits and bats I had to do to it. But that's the motor. A little bit of work to make it fit. It does fit. So I'm quite happy with that. Right, we'll just have a bit of a chat about the overall package, what you get with it, and then we'll look at something else. Right, what do we get with the package here? Like I say, I didn't want to mess around doing anything myself. I just wanted to get something and install it, that would be okay. So we get the control panel with the inverter drive and all the bits and bats in there. We get the cable which goes to the electric motor. We get the electric motor. We get the power supply cable with our plug on the end here ready. So all you've got to do is plug things in. Of course that's just for me. It's bloody typical, isn't it? Right, so we get all that stuff with it. So that's the AV400 Advanced Vector High Performance Speed Controller. Alright. I've got a couple of other Newton Tesla drives in here. All my machines run on inverter drives, variable frequency drives. Everything except, there is an exception to that, the drilling machine, the tool and cutter grinder and the bench grinder. They don't have that. You don't need an inverter drive on your grinders. You wouldn't want one of them because you need to know exactly how fast your grinders are working. It's really critical to know that because you need to know what the peripheral speed of the wheels are. Go too fast and you're going to have major trouble with them. Go too slow and you are going to have problems as well. They won't work properly. But there are limits on the speeds that you can actually run grinding wheels. So what you'll find is that you won't have variable speed drives on grinders. You might have different size pulleys. You might have step V-belt pulleys or flat belt pulleys probably on grinders. Flat belts are more suited to high speed drive than what V-belts are. But anyway, as far as our drives are concerned, let me just show you what we've got. Right, we're next to our friend here, the metal planer. Quite a favourite machine with many people. It is an excellent little machine. I've actually got a Newton Tesla drive on this as well. And I'm glad I put it on. It's worked very well with it. Let me just show you what the drive unit looks like. In fact, the drive unit, the control panel. It's exactly the same as the AV400, but it's a bigger one, this is, because here we've got a 1 horsepower motor. Can you just about see that? We'll have a better look at that in a minute. Let me just show you the control panel. One thing I'll just mention to you before we have a look at the actual unit itself. Where you site your controls on a machine is really important. Really important. They need to be in a convenient spot for operating the machine. So we saw on the shaper we had it on that on the operating side. You wouldn't want to put that around the back side. If you needed to get to that panel for whatever reason, an emergency or make an adjustment or something like that, you don't want to be walking all the way around a machine. You won't be able to get straight to the emergency stop or get straight to your controls. Have everything in a convenient space or a convenient area for the operation of the machine, and that's what I've done with the AV400 on the shaper, and I've certainly done the same with the metal planer. So I'm actually standing on the control side for the metal planer now. Let's now have a look at this unit. Now I've just mentioned that. So if you're going to put an inverter drive or something like that on your controls, don't put it You know, your machine's over here, don't put it on a wall 10 yards away. That's neither use nor ornament. You need your controls on the machine. Right, this is the control panel and inverter. It looks exactly the same as the one on the Shaper, but this is the AV750. It's much bigger. You've got the same facilities on here for the controls as you have on the Shaper. E-stop, start, ordinary stop, forward and reverse, and we've got the motor speed here with the jog facility. Again, I use this one, it's in reverse. So both the Shaper and the planer are configured so that reverse operation on the motor is the correct way for driving. Right, let's have a look what it says here then. Input supply, again, it's 200 to 240 volt AC single phase, 50 or 60 hertz. The output supply, 0 to 200 volts AC 3 phase, 5 to 60 hertz. Power rating 0.75 kilowatt. You know, that's a good 1 horsepower. Output current 4.1 amps. So there you are, it's a bit bigger. The reason I use a 1 horsepower motor is because when this machine, when I got it, it had a 1 horsepower motor on, so I thought, well, okay, I'll stick with that. I don't know what size motor it should have, so I'll put a 1 horse motor on. And as you've seen from some of the previous videos, it seems to work okay. We're certainly not overloading it, that's a fact. But there you are, that panel there is on the control side. I operate and control it from here, and it's at the front of the machine, so if I need to get it, I can. I don't have to go down to the far end of the machine where you could be, you know, in danger or something like that. Right, let's just have a look where the electric motor is. Right, there we are, there's the electric motor. It's overhead, and it's flat belt drive all the way through to the machine itself. Typical of machines of the 19th century, flat belts are really common. Really common. But there you go, so it's the same sort of package as the AV400. You get all the cabling and everything. The only thing with this machine was the cables weren't long enough. So what I had to do was get the electrician to put me another cable in for the feed into the unit. Because there's a plug at the bottom of the AV750 where it connects into the panel. So we just put the new cable in and connect it into the plug. So there you are. That's the drive on the planer. We'll have a quick look at the drive on the milling machine now. Right, I'm standing next to the universal milling machine, and this is the control panel. It's also got the inverters and everything in here. We can open it up and have a look. I'm just going to unplug it here, the mains. There you go. We've got no supply on there now, it's disconnected. Right, let's have a look and you'll see I've got my Turn Right Machine Works sticker on here from Keith Fenner. Keith was probably the first YouTube engineering type video I watched. There you go. That's the main motor. See, it's Mitsubishi. Main motor and Traverse motor. There's actually 3 motors on this milling machine. We've got the main drive motor, which is in the base at the back, drives up through the back of the milling machine. We've got the Traverse motor, which is on the left hand side, and we've also got in the base there's a sump and there's a motor in there for the coolant, but I don't have the coolant set up on this. We could do sometime in the future, but I'd need another drive for that, because that's a 3-phase motor as well. But you can see everything's in here. To change the speed on the Traverse motor, which is for the x-axis on the table, I have to alter it inside the panel here. And I have to change it in here with this little potentiometer, then I have to set it. The main motor, which is in the base driving the spindle, I can do that on the little control panel at the front. Now let me just show you that. See Newton Tesla. Let's have a look here. It doesn't give you any details there, it just gives you the quality control thing. Right, let's just have a look at the little control at the front. Right, we're standing next to the milling machine and you can see the control panel at the back there with the inverters in. You can also see down here, this is the local control panel. So I control everything on the machine off this here. And conveniently we've got the e-stop at the front as well, so if I need to do anything, it's at the front. That's where the original control panel is, because this isn't the original control that was on here. The original control was just a little push button station here, but all the contactors and everything were in the base down below. And you can see, just see the metal plate I put over the stop starts and all kinds of stuff there. So that was all in there, but now we've got the control panel here. And what I have here is, I'll bring you in closer so you can see this, because I'll just go through what we've got. Alright, this is the little local control panel. You see we've got main spindle here, which is the cutting head where the tools go. Forward, reverse and stop. This potentiometer here controls the speed of that main drive electric motor, so that's tied in with the main spindle. This little push button unit here is for the traverse feed, forward and reverse. Well, like I say, I've got to go in the panel to change the speed on the potentiometer, and the reason for that was that when I made my inquiry to Newton Tesla, they said, oh, we've done something similar to what you want, would this work for you? And they sent me details over what they'd done. I said, yeah, that would work, yeah. I would have liked another potentiometer here, but then you're looking at redesigning, so you'd have pay design costs and stuff like that. I thought, no, for what it is, I'm okay with that. The main spindle's the thing you want to change speed of. And I've got actually change gears for the main drive, or sorry, the X-axis traverse motor, which that is. I've got change gears for that, because you can spiral mill on this machine and you can do all kinds of fancy stuff with it. But anyway, there you go, that's a little control unit. It's at the front, so it's easy for control. You control the machine from here. If you're operating this machine, you're here. You're not 10 yards away. You're not hiding around the back by this control panel. You're here at the front. So you can do everything you need to. You hit that and everything shuts down. And that's it. So there we go. That's the Newton Tesla drives. The one on the lathe is a little bit different. We can have a look at that one in a minute. Alright, in one or two of my previous videos working on the shaping machine, we talked about additions to the machine, some of the things that you can do, and I mentioned a guy called Ian Bradley. Well, I've got his book here, The Shaping Machine by Ian Bradley, and it was a MAP technical publication, and MAP stood for Model and Allied Publications Limited. And this book here was printed in 1972. So one of the things we did talk about was an automatic feed on the tool head. Remember the tool head? So every time, if we're cutting down the side face here, like on the end of them stretches we did for the locomotive tender, I had to do it by hand. Every time it went in reverse, I would feed it around a little bit more. And that can be quite tiresome if you're doing a lot of that type of work. So if you've got an automatic tool head or feed on your tool head, that can be really useful. And we mentioned about bigger shapers having, a lot of them have got that facility. But on little shaping machines like this, you know, we haven't got that. Well, Ian Bradley, he made a whole load of stuff. It's a great little book to get hold of if you're interested in shaping or you know, shaping machines and using them. If you've got a shaping machine, it might be of interest to you, certainly would, I think. Anyway, he did an automatic tool feed, and I'm just going to try and show you this in the book. Can you see there? That's the mechanism there. It's driven from a quadrant gear here, which is fastened to the to the ram guide. I don't know if you can see that very well. But there you are, he's got a whole host of other things here. He's got little sections on additions to the uses to the machine, but you can see some of the drawings he's done here. There's no dimensional drawings. You'd have to work out all your own dimensions and things, but he gives a good idea. The assembly drawings here give you good ideas to what's required. See there, bit of a description, some calculations for the gears and stuff like that. There you are. Got a bit of an assembly drawing down here. So you can, I'm sure there'll be many other ways of achieving an automatic feed. Maybe you don't need a quadrant gear. Maybe you can use something else, some other kind of mechanism. But he did all kinds of stuff like that. Was the lock for the tool slide, and the little lock here. That's where that came from, out of his book. And he did another modification, which was to replace the little handle, screw handle on top of the feed. So what he did, he took that off there because it was a bit small, a bit cumbersome for him. So he put a bigger lever handle on, which is that unit at the bottom there. Don't know what else he did as well. He made all kinds of stuff and all kinds of interesting tooling as well. He actually made a little hacksaw type thing for cutting slots in round bar and stuff like that. So if you had to slit something, you could do it on the shaper. So it's a really interesting little book. I didn't pay much for this off eBay. It was only a couple of quid. So you'd probably get hold of this quite reasonably. So an interesting book. And there are some other ones out there, quite a few. I've got quite a few in the house. But really interesting, useful stuff. A lot of the things in here will apply to many different shapers, all different sizes. So there you are, that's a useful machine. A useful book for a useful machine. As you can see, we do use that quite a lot, that machine. And I'll just show you, we were doing the stretchers on here. I'll just show you where I am with the stretchers on the tender on that locomotive at the moment. Right, you can see what we've done here. I've got the two side frames here, and I've fitted the rear stretcher and the front stretcher. I've only drilled and tapped one hole at the moment just to get things in place. What I needed to do was to bolt this together so I could transfer punch the holes through here, and then I can drill and tap them. I've got the proper bolts on order that I want as well. So you can see we've got the draw hook will go here, and the buffer beam, the rear buffer beam will go there. The tank will go on top of that. The inner frames connect to that, Logan that one and that one. So we'll have two inner frames here, and they're going to be 1/8 of an inch thick. I made an arse of these when I was machining these on the milling machine. I made an arse of them, so I took too much off. So I had to redo my calculations, and what I decided to do, rather than have 1/16 plate, I'll have 1/8 plate for the inner frames. And that's what happens when your elbow knocks the soft jaws on your vise. Just tighten that up, but there you go, that's the frame, and that's where I am with that. I've got the material coming for here for the inner frames. I've got the new bolts coming for this. I ordered one or two other things as well, but we're making progress with it, nice and steady now, which I'm pleased about. I'd like to get the frame all sorted out. I'd like to get all these, the horn blocks and the axle boxes. Which one's that one? That's C2. That one goes in there. They'll fit in there, and then they can go up and down. The wheels fit inside here, yeah. And the horn chicks here will be riveted to the frames. But I'd like to get the chassis sorted out and done, finished with, because I want to get on with the tank and get the tank done. The tank will be a lot more work in the tank, but not a problem. We'll get it sorted out. So there you go. And you can't see in the footage there, I've actually done one or two other things as well. I'll just turn you around and you can see my splendid little welding bench. Alright, well look here, my little bench. Welded that up last week, finished it off, got the vise mounted, got a set of holes here which were the original holes for this. I was going to mount here, but when I marked the vise out on here on the plate, I actually did it with the plate upside down. I didn't realise that the slots here are not symmetrical, they're all over the place. So when I put the vise on, I thought, well, that's alright, and the jaws were like this at an angle, so that's no good. I did think about filling these in, which I could do easily, but I thought to hell with that. I'll just re-drill on the other side, so that's nice and straight and square and parallel now, the jaw is with the end of the bench. And I'll use these, I'll keep these here, these holes, for penance, to remind me to do the bloody job properly. This little holder here, I don't know if you can see it, this little holder here, that's where I'm going to put my electrode holder when I've finished welding. Just plonk it in there, and your rod sticks out here, your welding rod. Doesn't, because you've got nowhere to put it. The modern welding masks, which have got the automatic screen on them, you don't normally take them off. In the old days we had a handheld mask, and you put the handheld mask down and you put your rod in that, and that stopped it from touching the table. You haven't got that facility now because you keep the mask on. But anyway, there you go, it's all some bits and bats there for the for welding bench. Got my cables for my stick electrode stuff, I've got my cables for my TIG stuff here. There you go. Which I've still got to sort out. I've got to get this operational, the TIG stuff. I haven't got that operational as yet. That goes in there. But anyway, there you are, that's a nice little project I worked on. Gives me something to weld on now, and I can braze on here, and I can silver solder, I can do soft soldering, whatever I want. But quite simple, straightforward. I did think about putting some casters on there, maybe, for moving around or whatever, but it doesn't seem to be I'm not pressed to do anything just yet. Once I get using this more, then I'll decide what I'm going to do with it. But yeah, that was a useful little project. I like the idea of having something to weld on. And you need something steel, you can't weld on wood. Set it on fire. So there you go. That's something I've been working on. Right, well I hope you enjoyed that little video there. Give you some information on the drives, the inverter drives on the 3 machines here. I didn't go into the lathe. I can do that at another date. There's not much difference between the way that inverter drives on the lathe and what it does on the other machines here. They're all pretty much the same. One interesting feature I did like about the inverter drive was, remember when we had the crash? I can't remember what it was, part 2 I think of the setting up the shaper. I can't remember which part it was, but we had that crash and it stopped immediately, just tripped immediately. No damage done whatsoever. That's a good feature of the inverter drive, the speed in which it can react to overload for situations. I can't even speak now. So anyway, there you go. I hope it was of interest to you, and thanks for watching.